Okay, as we move out beyond the Earth, we actually move into the study of astronomy, because astronomy is technically the study of all that which exists beyond the Earth. And of course, there's a whole bunch of different components in the night sky. Some of what I'm about to show you and talk about is probably common knowledge to you, but there might be a few points that might surprise and delight you. We're going to move out from the Earth in a series of steps that take us progressively further into the universe and out to the outer edges, indeed, of the universe itself. And of course, at nighttime, we see the beautiful moon. But what is the most familiar object in the sky? That is, of course, the sun. We see it, of course, during the day only, but its reflection can be seen on the planets Venus, Mars, Jupiter, Saturn, and of course, its reflection can be seen on the moon. The sun is a luminous object. The planets are non-luminous. In the night sky, we have our beautiful moon, and that's the most prominent object on most nights, on many nights. It is our companion, and the two revolve around a central point. So the Earth and the moon, we think of the moon as revolving around the Earth, and that is true, but the Earth-Moon system also revolves around a central point. So as the Earth and the moon are moving around the sun, the Earth is revolving around the sun, the moon is revolving around the Earth and the moon are also revolving around a central point. It's the balance point, if you will. The balance point being the place where the masses on either side are equal. The balance point is known as the barycenter, and it's located just inside the Earth's mantle layer. And you can see in the diagram on the left and on the diagram that follows, right here, that the Earth and the moon revolve around this central point known as the barycenter. At distances beyond the moon, we find our planets. And along with the asteroids and the meteoroids, the comets, and other materials, that is what makes up our complete solar system. You're probably familiar with the names of the planets: Mercury, Venus, the Earth, Mars. And then there's the asteroid belt between Mars and Jupiter, followed by Saturn, Uranus, sometimes pronounced Uranus, and Neptune. And what about Pluto? Well, we'll see more about Pluto shortly. Here is Pluto. Here's where its orbit is located. It's in a very highly elliptical orbit that moves it inside the orbit of Neptune. But basically, Pluto is in an orbit shared with a whole bunch of other rocks, some smaller than Pluto and some larger than Pluto. And this belt of rocks is known as the Kuiper Belt. It's just beyond the orbit of Neptune, and sometimes these objects are called trans-Neptunian objects, TNOs. Pluto was discovered by Clyde Tombaugh in 1930, and these two pictures show the movement of a rock far out past the orbit of Neptune. And when Pluto was discovered in 1930, by means of these photographs here, it was a time of great rejoicing. Recently, Pluto has been taken off the list of planets, and the reason for that is because it's not the largest rock in its orbital sphere. It is one of tens of trillions of rocks out there, but one of thousands that are in the same size, if you will. And Pluto does not clear out the rocks within its orbit, as is one of the requirements to be a planet. And so, for that reason and others, Pluto is dropped from the list of planets. Beyond the Kuiper Belt, there's empty space, mostly, and then there is a spherical orb of dust and ice called the Oort cloud. And the Oort cloud represents the edge of our solar system. So we have the Kuiper Belt containing Pluto, and then beyond that is the Oort cloud. And the Oort cloud is famous because it contains the comets, or many of the comets. And comets, of course, will sweep in from the outermost reaches of our solar system close to the sun and then shoot back out into the Oort cloud. Now, beyond the Oort cloud, there's very little. It's mostly a vacuum that continues all the way to our nearest neighbor, Alpha Centauri. Technically. We'll see more about that in a second as well. The edge of the Oort cloud is about a light year, or about 9.5 trillion kilometers from the Earth. What is a light year? Well, a light year is not a measure of time, but it's a measure of distance. It is how far electromagnetic radiation, in other words light, will travel in 365 days. The distance traveled by light or by electromagnetic radiation in 365 days. Now, the speed of light is 300,000 kilometers per second. So to calculate a light year, you multiply the speed, 300,000 kilometers per second, by the number of seconds in a year. 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year. And when you do that multiplication, notice that the units cancel out except for years and kilometers. And you end up with a number in kilometers per year. What is that number? Have you had a chance to work it out? It's about 9 trillion 500 billion kilometers, about 9.5 or 9.5 trillion kilometers. And the symbol for light year is Ly. So it's important to remember that a light year is a distance and not a measure of time, even though it sounds like a time unit. And going at the speed of light then, how long does it take for light to move from the Earth to the Moon? About 1.3 seconds. Light from the Sun reaches the Earth in about 8 minutes, or about 500 seconds. Light from the Earth travels to Mars in about 13 minutes. So we say that Mars is 13 light minutes from Earth. And from the Earth to our nearest star, which is here, our nearest star, they've used the term Proxima Centauri, and Proxima Centauri is about 4.22 light years away. It's a star that is associated with Alpha Centauri, and we'll see a little bit more about that shortly. And here, if we move across our Milky Way galaxy, if we go from the Earth out, it's about 52,000 light years. Now, we'll see this later on, but the distance here, the long distance across the Milky Way galaxy, is about 120 or 115,000 light years. The thickness is about 15,000 light years. So as mentioned, the nearest visible star to the Sun is Alpha Centauri, and that's the nearest visible star to the Sun. Alpha Proxima is the nearest star, but you can't see it. And so we'll consider Alpha Centauri to be the closest visible star to us. It's about 4.3 light years away, about 40 trillion kilometers away from us. So there's Alpha Centauri on the left. Here's Beta Centauri. And they're part of a constellation which goes up and around here, which we can't see all of it. It's known as Centaurus. And here, this cross is known as the Southern Cross, or Crux. But Alpha Centauri is about 4.3 light years away from us on Earth. And in order to grasp how far that is, I'd like you to consider doing a problem. Let's say that we had a spaceship moving away from the Earth at 50,000 kilometers per hour in a straight line towards Alpha Centauri. Well, no, let's do a little bit better than that. Let's imagine that we have a spaceship that can move at 100,000 kilometers per hour. Current spaceships travel at about 35,000 kilometers an hour. Let's say we could make one up that would travel at 100,000 kilometers per hour. If that was the case, how long would it take for this spaceship to reach Alpha Centauri? Now, when you finish the calculation, certainly pause this and work out the calculation if you want to. If not, feel free to wait for an answer to appear for you. But when you attempt this and come up with a final answer, put the answer in some unit that makes sense. You know, like days or months or years or whatever, don't put in something like 2.47 times 10 to the 9 seconds, because you wouldn't really talk to somebody and say, well, it's going to take you 2.47 times 10 to the 9 seconds to get to a place. That just wouldn't make any sense at all. So what I'd like you to do, if you don't mind, take a moment and try and do this calculation. How long would it take to get from the Earth to Alpha Centauri? The distance to Alpha Centauri, which is here, 4.3 light years, and the time 100,000 kilometers per second. Now the answer to this is found on a document attached to this lesson, so feel free if you want to consult that, and then we'll pick this up in a moment's time in the next session. Okay, bye for now.